In this example, we are going to look at another trinomial where our a term is not 1. But this one's a little bit different than the ones we looked at in a previous example. So we can see that our a term is not 1. Right here we have an a value of 2. But in the previous example, we also had a GCF. And as soon as we factored out the GCF, our a value was 1. But if I look at my trinomial 2x squared plus 11x plus 12, there is no GCF. 2, 11, and 12 don't have anything in common. So if I try to use my old method of factoring, I would look for factors of 12 that add up to 11. Well, in my list of factors of 12, none of them add up to 11. 1 and 12 don't work, 2 and 6 don't work, 3 and 4 don't work. So you might want to just say prime on this one, but remember we had a discussion about that. It's not always prime unless you've exhausted all possibilities. And now there's a possibility of something that can be done with that a value of 2. So the fact that our a value is 2 adds a whole new layer to how we're going to factor this. We're going to use a method that's really cool. In the notes here, you see it's called the grouping method. I also call it the AC method because it's cool, like air conditioning. Just kidding. It's the AC method because we begin by multiplying the a value times the c value, and we obtain 24. Then the second step is to find factors of 24 that add up to 11. So my factors of 24 are listed here, and now I want to choose 3 and 8. And the reason why I want 3 and 8 is because 3 plus 8 equals 11. So I'm multiplying the 2 times the 12. Technically, we were doing this before when the a value was 1. We would multiply 1 by whatever the c value is, but you would always just get the c value. So we didn't do it because it didn't matter. But now it matters because our a value is something besides 1. So I've chosen my factors 3 and 8. Now step 3, here's where the cool part comes in. So I'm going to rewrite my trinomial, that's 3 terms, and I'm going to break up the middle term, that's the bx term, and I'm going to break it up using the factors of 3 and 8 that I chose, and I'm going to create a polynomial with 4 terms. So you'll notice I broke up the 11x into 3x plus 8x. So it's still the same polynomial, I just uncombined like terms. I took the 11x and split it up into 3x plus 8x because now that allows me to factor by grouping. That's why this is also called the grouping method. So if I look at 2x squared plus 3x, the GCF is x. So I'm putting a 4 there because now this is step 4. I'm going to factor by grouping. So I take out an x and it leaves behind 2x plus 3. Now I look at the second part of my problem, the plus 8x plus 12, that also has a GCF, that has a GCF of 4, but when I factor out the 4, it also leaves behind 2x plus 3. And remember, what did I say? This is when you do your happy dance. We do our happy dance because our binomials match. That means we're on the right track. We're going to solve this correctly. So I'm ready for my final answer. I take my x plus 4 to form one binomial, and then I take my matching 2x plus 3 to form the second binomial, and now I have my factored version, x plus 4 times 2x plus 3. But we technically aren't done until we check. I'm just going to rearrange the binomials because people always ask me, does it matter what order I put them in? No, it doesn't. You could put the 2x plus 3 first and the x plus 4 second. So let's do our check. We're going to get 2x squared plus 8x plus 3x plus 12. And now when I combine like terms in the middle, the plus 8x plus 3x, hopefully you notice that from up above in step 3. Hey, there they are again. That's all we're doing when we're factoring is we're undoing the FOIL process. So we're going to see those terms reappear. But down here in my check, when I combine the 8x plus the 3x, I get my plus 11x in the middle. So I know that my final answer is correct. Yes, now we know how to factor when our a value does not equal 1.